special guest today from a special company. Probably you already know about it because there is the agenda and the speaker, so there's already a spoiler. Before we go and introduce the speaker and the agenda, I just would like to thank Qualcomm, the wireless research software department, which is sponsoring this event. Thank you, Qualcomm, for paying the meetup fees, especially my VP, Charles Berman, which is supporting this meetup. Just quickly, we have our Dropbox where we place presentations and material. We do have Slack channel. We do have Discord that you can join. If you don't have access, please let me know. We upload the San Diego C++ meetup recording, which I hope it's recorded right now. My machine doesn't act on me. We have a SDCPP meetup YouTube channel, and I usually upload that within 24 hours or less. We have recent sessions in the channel, so feel free to browse it if you are interested in. We have a Twitter handle, SDCPP Meetup, which I'm managing. My specific meetup, my specific Twitter handle is Kobe_CA, and I tweet about C++, obviously Conan, software engineering, Python, Rust, and everything in between. I'm also sometimes blogging in Martin's blog pages, and also uploading links to the meetup after the session. So we basically publish the meetup in various channels, including Martin's blog post. So again, today we have a special guest speaker from a special company, JFrog. I'm not gonna talk about the whole agenda, kind of the abstract, because you had it in the meetup page. Just the title, from the command line to make to CMake to Conan by Nick. I'll just quickly, Nick, if I may, I'll just talk about your bio. Nick started in the video games industry, developing titles for console and mobile. Disappointed by the oppressive corporate feel of traditional technical training, Nick's passion is to create more engaging and powerful learning experiences through game-based learning and other playful techniques. As a curriculum developer at Oracle, he focused on Java programming and certifications. As a developer advocate at JFrog, his focus is on C++, Conan, and other JFrog technologies. Welcome, Nick.
Well, thank you. Yeah, I'm glad to be here. Thank you for having me.
Yeah, so before we start with your presentation, we have something special from Ari. So Ari, you can go ahead. I'll stop sharing, and you can go ahead and share.
Awesome. Thank you so much, Kobe. Hi, everybody. I'm Ari Waller, and I have the pleasure of being the Meetup event manager for JFrog, which is the home of Conan, the open source, decentralized, multi-platform package manager for C and C++, which you're going to hear about tonight. We're very excited to be here with you. I've always been an admirer of Kobe and his commitment to not only the C++ community, but the several other communities that he supports as well. It's not an easy job. Sometimes it seems like a thankless job, I know, but I can tell that everyone here really appreciates all the efforts that he puts in there to keep the San Diego community up to date on C++. I know you are all here to hear Nick tonight talk about command line to CMake to Conan. And I want to just share very shortly, one of the reasons I love working for JFrog so much is because we have a core value, which is community happiness. And in that spirit, I'm going to go ahead and share my screen really quick. JFrog would like to do a raffle for a Amazon Echo Show. This is not the small one. This is the Amazon Echo Show 8. It's really cool, and my kids fight about it all the time. They prefer to watch this than their television set. I can't figure it out, but they do. You can enter the raffle with the QR code, and Kobe's going to go ahead and drop the bit.ly link that I sent him in the chat. Now, due to corporate compliance reasons, I can't do live drawings over the internet. However, a winner is going to be randomly selected within 3 business days. And once I contact them and they claim the prize formally, we're going to share their name with the entire meetup communities. But the best part is there's no loser tonight because everyone that enters the raffle, I'm going to email you so I can mail you a Conan t-shirt. Now, Kobe is modeling that t-shirt for us. I wear mine too often, and I wasn't able to get mine on tonight. I have a different Conan t-shirt on tonight. But the one we're going to be sending you is Conan the Frogarian. So we would love to get those out to all of you to enjoy just for being here tonight and entering the raffle and so forth. So I hope everyone is here and will enjoy the talk tonight. I know we have people from the Conan team here tonight to answer some questions in the chat as well. We have Diego, which is an awesome honor for him to be there if you have questions as well. So we're excited. So Kobe, I'm going to turn this back over to you, and thank you so much for everything that you do.
Thank you, Ari. Thanks for the warm words. I a big advocate of package manager, specifically Conan. People that work with me know that a lot. How much I push that. Jim would probably yeah. So I also had the pleasure to attend the Swamp Up in Carlsbad a few weeks ago, which I had a blast. Although I am a C++ developer, I really like the whole infra, and I think JFrog is in the basically controlling everything. In my opinion, that is related to infra and CI/CD and containers and everything that you can think about. So that's it from me. I think, Nick, this is your show. Go ahead and start.
Okay, great. Let me just go ahead and start sharing my screen. So are you able to see my screen okay?
Yes.
Yep.
Works fine.
Yeah.
Okay, great. Actually, let me just double check to make sure that I didn't. So I have to check a box here for include system audio because I have a video that I can show that'll demonstrate a TinkerForge piano, an infrared piano. Just want to make sure you could all hear the beautiful tones. All right, yeah, so let me just go ahead and get the presentation started. All right, yeah. So I'm Nick Ristuccia. I'm a Conan developer advocate at JFrog. Glad to be here. Thank you for having me. And I want to present about my experience of going from the command line to Make to CMake to Conan. A little bit more about myself. So my background's there's a bit of robotics and there's a lot of game design type work. I just wanted to focus in on maybe some products that you might find interesting. So for robotics, the work that I did there was programmed in interactive C. So it's C syntax. So you have custom functions for the effectors, like your motors and your servos, and this various sensors. Like there's an infrared distance sensor, there's a sonar, there's a camera, beam break sensor for an encoder. You can measure some back EMF. The controllers for that would be Fred Martin's Handy Board and Charmed Labs XBC. Charmed Labs is still around. What I found really cool about this was you had the Game Boy Advanced as part of it from Nintendo, so that would act as the interface. It would also access the processor on the Game Boy Advance. So yeah, that was pretty cool. As far as games, yeah, I've developed games for various consoles from Microsoft, Sony, Nintendo, iOS, Android, and web. And they've been done in various languages. So that could be action scripting, Lua, JavaFX, C#, SQL, that'd be for access to a database. And one project that might be particularly interesting here was the game Power Gig. This is for PS3. At the time, I was working as quality assurance on the team, but it's in the same vein as say Rock Band or Guitar Hero, where it's a beat matching game. But the studio wanted to actually have a game with a 6-string guitar, and it seems like this would be a really good use case for C++, considering that C++ has like the most performant access to hardware in games. Any little bit of lag, even like just approaching on the order of 100 milliseconds, is enough to drive a player nuts. So if you want to have a peripheral that has like as minimized an amount of lag as possible, it seems like that's a good candidate for the peripheral. The way it would work is you have a small current going through each wire, and then when the player presses it down, that would make contact with the metal bar between each fret, and that would complete a circuit, so you'd be able to tell what notes are being pressed that way. Also, we're developing Java training and certification from Oracle, which Oracle sometimes has this, yeah, just like a corporate kind of feel to it. I very much want to try and get away from that. So last big gamey project that I worked on was a game to teach Java programming concepts, object-oriented thinking, class design, inheritance, Lambda expressions, and multi-threading. Also able to showcase data visualization by connecting to the Oracle Autonomous Database. But now that I'm at JFrog, my focus is on JFrog Technologies, Conan C++. So a couple of projects that I'm working on. There's a C++ library card game. So this is like, if you ever played the card game Apples to Apples, it's like that had a baby with the TV show Shark Tank. So you'll have various C++ technology cards or libraries, and each player has to pitch why they believe their library is good at fulfilling the scenario that the judge has, but the judge is going to have these like science fiction type scenarios. So it's up to you to figure out, okay, how can today's technology power the starbase? How can we mine the crystal asteroid? How can we do all this great science fiction type stuff? I definitely want to go in that sci-fi direction because I feel like that's great at just getting you to have this sense of wonder and thinking critically about how the world came to be and just the possibilities of technology. Another thing I'm working on is a CMake course. So the idea here is that, say you have someone who's learned a little bit of C++ through university, or they do it as a hobbyist, learning CMake would be that next logical step as far as growing your expertise and building up your ability to handle more complex projects. And that was originally the impetus for what this presentation was supposed to be, but I get the sense that there's definitely a lot of expertise that comes to these meetings. So I want to focus more on the Conan side of things and not so much on, say, the command line hello world side of things. But I wanted to use the C++ infrared piano as a backdrop to and just to contextualize everything. So the piano itself was a really fun way to just get myself reacquainted with C++ and transfer what I had been learning about CMake. And the CMake, I hear that CMake practices have been evolving over the past few years, and this project was just an opportunity to from the get-go learn the modern CMake approaches. So as far as how the infrared piano actually works, I have a video that'll speak to that effect. Let's see if I can just get that pulled up.
These are sensors and devices from TinkerForge: an air quality sensor, analog joystick, linear potentiometer, speaker, LCD screen, infrared rangefinder, and there are many more. We've used some of these devices to create an infrared piano. 2 IR sensors detect where you place your hand over 2 sets of keys. The speaker beeps at a frequency matching the note for that key. The LCD screen prints the distance detected by each IR sensor, and the linear potentiometer controls volume. The software to do this is written in C. It uses the C TinkerForge bindings, which are available from ConanCenter and can easily be retrieved using the Conan C++ package manager, along with many other libraries that you may feel inspired to use as part of your own projects.
I'm going to assume the audio worked because no one said otherwise. Could you hear that okay?
Worked well. Yeah.
Fantastic. Great. So, okay, let's get back to. So yeah, just an overview of what that piano is all about. So a lot of the hardware came from all of the hardware, except for the Connects, came from TinkerForge. So TinkerForge is a German company, and they provide various sensors and devices for these maker type projects. They support a variety of languages, and this would include bindings for C and C++, and they're quickly available from ConanCenter. So how to go about using it, just like the video had shown, just a quick matter of retrieving those from Conan, and then within the actual source code, go ahead and include whatever headers that I would need, and then I'm free to call whatever functions that I would need from the library. Within CMakeLists.txt, this is where I could use find package to find what I need, and then I'll create the executable and then use target link libraries to link that library to the executable. And then from there, it's just a matter of from the command line, we'll call CMake, create our makefile, then call make to compile, and we are free to run the program. But there's a lot of ideas that I had just thrown out there. There's Conan, there's CMake, the command line, there's make. And as someone who was new to this, uh, trying to wrap my head around all this was a bit of a process. So I definitely want to take a step back and try and contextualize all of that and show how something like this can be put together with relative ease, a project like this. So yeah, so that's where the name of the talk came from. We have the command line, make, CMake, and Conan. So as a whole, these helped development go pretty quickly. I was able to get a Hello World program going within a day, and this is just me getting the LCD screen to print something. And the actual piano was honed and troubleshot and completed within about 1 to 2 weeks. And it was a real pleasant change of pace compared to other technologies that, I hear about a technology that'll come down the pipeline. I'm curious to try it out, but for whatever reason, it's tough to get it to work. And maybe something doesn't work as advertised, if at all. Maybe there's like additional dependencies that I need to hunt down and prepare, or lots of settings to fill it with that maybe or may not be properly documented. See, I definitely as someone new to this, not having a clue how to get started or feeling that progress is always out of reach. That's a you know, I was thankful to not be put in that type of position because everything seemed to work as smoothly as it did. But yeah, just that perspective is like as a game designer, there's like no worse feeling to create within a player feeling like your progress has been robbed for you, or no matter what you do, you can't move forward. Definitely want to avoid that. So yeah, let's as far as like each individual layer though, yeah, these could represent their own separate mystery as far as what are these layers and how do they work with each other? What benefits do they provide to developers? And just what I like to do with the curriculum that I develop is find what it is that clued me in and then try to reproduce that for other developers to help them learn more smoothly and avoid any sort of dead ends or unnecessary banging your head against the wall. Not that there definitely is value in struggle, but have the struggle be a bit more like smooth and lead to better learning results. So let's start with C++, trying to get myself reacquainted with the language. And so my frame of reference was Java. And so just starting with a fact about C++, what was different was here we have a platform-dependent language, which means that the instructions that would be written for one machine like Windows wouldn't be meant to run on a machine like Linux. Okay, but this also means that the artifacts could be optimized for their respective platforms. And so it makes sense when I was researching that why for a long time, C and C++ had been the choice for the most performant access to hardware. Java, by comparison, would be platform independent, where the code and the assets are supposed to be written once and then can run anywhere there is a JVM, a Java virtual machine. And so then the challenge becomes for the language's authors, how do we prepare the JVM for an array of platforms? And of course, Sun's and Oracle's solution for this to ensure performant access to the hardware for the JVM was to write it in C and C++. Specifically, they say they wrote it in C using C++ libraries. The compiler itself is written in Java, but the JRE, Java Runtime Environment, that's C, and that's the layer that is necessary to interact with the hardware. So Java would be an example of a large C++ project. And just to get a sense of scale, maybe also a comparison against JavaScript. So there's an article here that says that a huge JavaScript project is 18,000 lines. What would you define as a huge project in C++? I think there might be a poll for this. Would we be able to throw that up, or should we just shout it out or put it in chat?
No, Paul, unfortunately, I couldn't make it. So maybe people can either shout it out or put it in the chat.
18,000
So-
lines, a very small C++ project. Think closer to 1 million.
Yeah,
He's-
million plus would be probably you.
Yeah. So we did this survey, I think it was a couple of years back, and that's exactly what we found, that the majority of people said it was over 1 million lines, and a good number of those people would say it's actually closer to 10 million lines. And so this seems like this would present a challenge, right? That, if you want to have the most performant access to hardware, well, you may encounter some long build times, given that you're going to have on the order of 1 million or millions of lines of code. And this is also the finding from the 2022 annual C++ developer survey from ISO CPP, top pain point, long build times. So I feel like it would be good to keep that in mind as I'm learning. How do I avoid situations like that? So getting myself reacquainted with C++. First thing I wanted to do was just create a simple hello world type program. So we'll have our source code greeting.cpp, just a simple function, print a greeting, hello world. Something that was missing in Java was this idea of headers, where I would need to declare a function before being able to make use of it. So there we have our greeting header, and then we have our main function within main.cpp. So there's our source code. Next challenge is, what do we do with this? And that's where the command line comes in. So we have what's .cpp files and header files, which are more or less human readable. Then the goal is, let's convert it into something that can be read by a machine, our object code, and then link that with platform specific libraries into a greeting executable, done through various commands on the command line. Okay, so that works, although I'm expecting that as projects grow to millions of lines across many more source code files, that this manual process of specifying what to compile and link, it seems like this could get error prone or tedious or slow in one way or another. So that's where Make comes in. And I found that Make would make a difference. So what's one way to save time compiling, or at least with the process, would be to not to recompile everything, only to recompile files that may have changed, and that's what I saw as a value of Make and Makefiles. So if we could automatically detect changes, then we'd save time by just not recompiling that, and there'd be no human error if I'm able to automate some of that stuff as far as what to call, what to detect, what's the proper order of things. So this Makefile, for example, We have our targets, we have our greeting, we have our main.o, we have our greeting.o, and these are the files that would need to be compiled. And the triggers to do that, it would depend on, is the change going to be detected in our main.o or greeting.o, because that's when we need to relink everything to our executable. How about the greeting.o? Well, if there's a change in the greeting or the greeting header, then we would need to recompile. And the statements to do this is just taking the command line statements from before. So okay, now I have some context for how this is all fitting together now. If I go ahead and run from the command line, run make, if I do it fresh, so it looks like I'm going to have all three of these statements run. But if I were to change the greeting afterwards to, let's say, Hola Mundo, hello world in Spanish, and compile again, then only the greeting object code and the executable seem to recompile. So main.o, which was unchanged, hadn't. And so I'm thinking, okay, now if I scan this up to, say, 1,000,000 lines of code, and the number of source code files increases proportionally, so then I should be able to save a significant amount of time by not recompiling stuff. One drawback, though, seems to be a degree of inflexibility. So what I've written here manually, it works for G++, but there's a lot of other compilers out there. So what could I do to get more flexibility? Is there any way to automate this or to not have to write the make file myself? And so then I found out, okay, this is where CMake comes in. The advantage here is that with just a couple, simple lines in this example from the TinkerForge project, one CMakeLists.txt file was able to generate what would be needed for a variety of configurations. So maybe that's a make file for G++ on Linux. Maybe that's instead a Visual Studio project for MSVC for Windows. Great. So then there's also the ability from the CMake lists text file to declare artifacts that would need to be generated. I can use this to create my libraries, my executables. Here you can see we're adding the executable for our piano, and we're also finding the package, which would be the libraries that our program intends to consume. And we also have the ability to link libraries. We could include various directories and specify the degree of visibility between targets being public, private, and interface. Great. And because this will, when I go ahead from the command line and call CMake, this will produce that make file on my behalf, and it should be a lot more robust than what I had wrote manually, and I don't have to go back and manually edit that make file or anything like that. So great. I have some more flexibility. And this is where libraries come in. Because what I want to do is I certainly want to make use of the TinkerForge libraries, and the millions of lines of code for these projects seems to be in no small part coming from libraries, which would make sense. Why reinvent the wheel when libraries already exist to offer the project the functionality that I'd like to leverage? So give yourself 100 points if you know what each of these libraries are. POCO, for example, modern powerful C++ libraries for building network and internet-based applications that run on desktop, server, mobile, and embedded systems. RT-MIDI interact with digital music devices by using the real-time MIDI musical instrument digital interface input-output library. Podofo would be for parsing, modifying, and creating PDF files. LibMySQL client interact with a MySQL database from the C language, and Point Cloud library would be to assemble and process many 3D spatial measurements into a data set that represents a 3D object or shape. And so great that we have that functionality available, but also according to the ISO CPP survey, managing libraries tends to also be a major pain point. So then what can be done about that? And well, maybe just provide a little more color. What do we mean by that? What exactly are the pain points? So I started exploring some of these libraries, and in part that was because I wanted to figure out, what would be a good, library, a good candidate for the card game I'm working on, but also just to get a, get a sense of the ecosystem. So here's kind of what I found. Say you have library A and it has the functionality that you think would be great. It wasn't as simple as just going and getting it. It turns out, hey, library A also depends on library B, and B happens to have its own, complex or unique build system, and getting it to work for the configuration that I have, that may not be so easy, because often open source libraries might be produced with only one configuration in mind. So I could try getting that to work, but and maybe I succeed. If I do, what's my reward? It turns out there's also other libraries that we are dependent on, and those depend on other libraries. So yikes. Okay. Just a couple of real world examples of what some of these might be. I had mentioned Point Cloud Library. So not only do I need to just get Point Cloud Library, but that library also has a dependency on Boost, on Eigen, on Flan. Quite a few dependencies here. VKT, Visualization Toolkit. So let's say I want to go down the rabbit hole. Let's get VKT all set up. Are there instructions for that? There's instructions for a lot of these. Here's a note that I found interesting. If you want to build a point cloud library GUI tools, you need to build VKT with Qt support. So obviously you need to build and install Qt before VKT. So it just seems like, I hesitate to say where does it end, but that's the kind of the sentiment that I'm getting. So point cloud library, I don't believe is currently offered through Conan. ConanCenter. And so I actually kind of hesitate to go down this rabbit hole, because in order to have a library offered through Conan, it has to be certain criteria of being able to run on some of the most popular configurations. So if it's not there, I'm kind of hesitant. Like, does this mean that there's things that aren't going to be supported? Am I going to spend all these hours getting this branch of dependencies to work, this other branch of dependencies to work, going down various rabbit holes, and maybe one of them is going to be this curveball or a dud that's going to be a gotcha. Hey, it turns out all that work you did, this part here doesn't work for your configuration, so all that goes to waste. That would be quite disappointing after putting in all that work. It kind of gets back to that feeling of one of the worst things for a game player is to lose all your sense of progress. So yeah, let's if we can avoid that type of scenario, if we can have a lot of this stuff done, do it quickly or somehow automate some of this, that would be quite the value proposition. So this is where the CMake this is where the Conan package manager comes in. So Conan recipes ended up making this process a piece of cake. So there's over 1,300 recipes on ConanCenter, and these recipes will list all the dependencies for a particular library. It will provide license information, and it allows developers to get the libraries as binaries for a variety of configurations and versions. And so that's a big time saver. I don't need to do this stuff manually. I can just get the binary already compiled from ConanCenter. Sounds great. So for each of these configurations, there'll be a package ID. So if you and your friend request the same library and your configuration is the same, like the architecture is the same, you have the same compiler, you have the same operating system, you'll both get the same binary with the same package ID. But if something in one configuration differs, like say you want to request a shared library instead of a static library, or you want release instead of debug, or you want GCC instead of a compiler, any sort of variation like that is going to result in a different unique package ID. And so Conan will use this package ID comes up in various places with Conan. So for example, it's also the package ID is also a fundamental part of the directory structure that would store the Conan packages. And I can show that in just a little bit. So I had mentioned POCO earlier, and these would be all of the all the libraries that would need to come along with POCO. So quite a few, but thankfully it looks like I can get what I need from Conan, which is, hey, great, from the command line. So I'll just go ahead and demonstrate that, and then I'll go ahead and break down the Conan file.txt that you see on the screen. Okay, let's see here. Okay, so here I have my command prompt, and I'll go ahead and pull up the folder so you can see all these things getting populated. And then so right here, what am I requiring from Conan file.txt? I'm just requiring POCO. And then it should do the job of getting all of the dependencies that I need by just calling Conan install .. meaning just the one directory back, which is going to house the Conan file.txt. So go ahead and run that. There we can see everything. I'm getting everything that I seem to need right here. And so this is nice. I can, lay back, have a little stretch, and just watch it all take care of itself. There's not this going down the rabbit. I'm kind of thankful right now that I don't have to go down the rabbit holes, and hopefully everything should come together as expected. And it does each time I've tried. And so that's one thing I definitely appreciated about Conan, is that it just it works quite smoothly. Yeah, there we go. So we have what we need right here. If I were to drill down just a little bit, let's say I want to go down into, oh, I don't know, what would be good? OpenSSL. And we should see here that we have our package. This looks familiar, our package ID. And we have licenses. Great. We have our actual library. And we should have, what do we need to include? Yes, we have our header files. Great. So we're getting what we need, and that was fast. That was great. All right. So go ahead and go back to the presentation. I'll explain a little bit more about the about Conan file.txt. So taking a look there. So we specified the requirement for POCO, and the recipe for that would be retrieved from ConanCenter, ensures we find everything that we need. As far as generators go, so Conan should be able to accommodate any number of generators. And the process is pretty similar if we were to require instead something from Visual Studio or Auto Tools. We happen to be using CMake here. So CMake toolchain as a generator is the latest way to have compatibility with CMake, and then CMake deps generates the find package module needed to find the binaries when they're getting referenced later from the CMakeLists file. So in fact, with the binaries already compiled in a known location, they can be reused across multiple projects on the same machine without recompilation. That's assuming that all of my configuration requirements would be the same. So here, maybe let's try and throw in a little bit of a curveball. What if I want to mix it up a little bit? What if I want to instead have some options, like instead of a static library, I want a shared library. So some of these configuration settings are within our control. Some of them aren't. So for example, if you're working on a Windows machine, what's the sense of trying to get something for Mac? But options as far as like shared versus static, that's something that we have within our control. It's just a simple matter of specifying the options right here, and then we can get what we need. quickly as well. So I'll take this file right here, add the options, and install again. It'll skip over some of the stuff that we already have, and so we'll just go about. Oh, it retrieved it as I was talking. So then we have our package, which should contain the shared library, and we have a different package ID for that. Yep. Okay. Yeah, quite smooth. So let's see now. And sometimes, if some of these things aren't specified, by the way, it's the recipe will provide default values. So in this particular case, a default value for the library that we retrieve would have been a static library. But just at a high level, what a Conan recipe is, it's a Python file, and it describes how. So here it describes how this package artifacts are built from source, and some functions or key functions that are included would describe source would be how to get the source, build to be how to build from source, and package would be how to start the artifacts and create the final package. So the next task, we have the TinkerForge bindings that were provided from that company, from TinkerForge for C++. What's the process of getting those into Conan so that other users can benefit from how fast it was to retrieve the stuff that we need? And so the requirement is to ensure compatibility with major platforms. That would be according to the specifications here on this slide. So yeah, enough binaries would need to be generated, provided, and available so that developers can consume them, compile, and link on all the platforms configurations that are shown here. In the case of TinkerForge, this resulted in 60 binary packages available on ConanCenter, each of course with its own unique package ID. So if I were to go into ConanCenter, have a search for TinkerForge, there are the TinkerForge bindings. Yeah, so 60 different configurations, and these will all vary. Some of them will vary by operating system, they'll vary by architecture, they'll vary by the compiler that we're looking for. ConanCenter would also provide instructions on how to go about using these libraries, and I'll discuss a bit of overlap with the content on this page with the next few slides that I'll talk about. It'll list whatever. We also have our recipe available here, and it'll list whatever dependencies we have. Coincidentally, TinkerForge doesn't have any dependencies, but if I were to search for instead POCO, then you'd see that that aforementioned longer list here. So great. And if we were to just drill down to see what exactly is within that TinkerForge package, it's pretty similar to what we've seen for some of these other ones for OpenSSL, for POCO. Go into TinkerForge right here, and we'll see that we have our package. There's our package ID, and we have our license, we have our library, and then we have the header files that we need for all the functionality for the various sensors and devices. Great.
Nick, is it okay to ask a question?
Sure.
I can wait if you want.
I guess we do it now or until the end. There's also a chance that I might answer with the next couple slides.
Okay, I'll wait. No problem. Okay.
I'm glad you have questions, though. Thank you. So yeah, we went ahead and examined the TinkerForge package. And so yeah, just to retrace the steps that we had done, I had provided this in an overview before, but yeah, just what all we got to do to retrieve the packages that we need for Conan from the we have our Conan file.txt specifying the TinkerForge bindings are what we're looking for. We specify the generators, and just from the command line, go ahead and type in Conan install ... and then we should be good. It's yeah, quite smooth and just as fast as we had seen from the POCO example. In fact, if I wanted to, well, let's say I have this, I'm a very eager type of designer, and I'm like, hey, wouldn't it be great if we had something like RT MIDI? That way I can recognize the notes that are being played, and then I'll have Podofo for creating PDFs, and I'll create a sheet music based on those notes and print that out as a PDF. So this kind of it becomes quite easy to get what you need to start developing, and indulging this kind of feature creep. That's not to say that implementing the features themselves is going to be trivial. It's not, but at least you can focus on, instead of the legwork, like the getting started kind of stuff, the focus is then instead on the actual development. So again, yeah, just go ahead and include the headers within the source code files. We have a couple of examples here of the various headers we're including. Then we call whatever functions that we need. Then go ahead and find the package from our CMake list. It is in a known location. And we go ahead, create our executable, and then using target link libraries, we'll link that libraries that we just got to our executable. Great. So yeah, it's such a relief to just be able to get to work and focus on the programming side of things. And so TinkerForge, actually, they're quite good at providing documentation. I really appreciated what they had done. So here is an example of, so this is the sample code for their linear potentiometer. So we'll go ahead here and include the headers within the source code, and we have our callback function. So this is going to be called periodically. In this case, it's just going to print the value of the sensor. I think it's going to be somewhere between 1 and 100. And then within our main method, go ahead, create the objects for our connection, our device, connect them, and then ready our callback function, and then go ahead and set the configurations a bit. Something of note here is going to be the 250. There'll be the 250 millisecond delay in between when we're getting the reading of the linear potentiometer. And depending on the rate of this callback, that was actually pretty significant in terms of how the application, or how the piano was going to function. So I have a couple of examples of how that all went down, just from a design perspective. So for example, design considerations for this segment display. Originally, I wanted to have 2 of these segments displays, and they would each print out the distance that is measured by the infrared rangefinder as millimeters. So it could be anywhere between 100 and 800. And it ended up being really slow to update. If I had a low callback rate, meaning that number is very small, and I wanted to update quite frequently, the lag was huge. Sometimes it'd be like 10, 20 seconds until the proper value was shown on the segment display. And the reason why I went low, so I was thinking in terms of like frame rate lag or delay. That's a really good way to like break that sense of immersion and frustrate players in a video game. So I thought if I had it as small as possible, that would be better to make sure that the information was as accurate as possible. But it seems that this particular sensor wasn't able to accommodate that, at least with a low callback. I could have it high, which means it updates a lot less frequently. This risked being inaccurate though. So it was very possible to, so it takes the reading, you put your hand there, you remove your hand, and it never actually updates to signify that your hand was actually there, to give it a measurement. It's as if it never actually happened. And so, yeah, this was, I didn't like that, say, lack of accuracy there. And so as cool as I thought the sensor was, it has this like 80s retro feel to it that I love. But as much as I wanted to use that, I decided let's go with LCD display instead. For the speaker, the goal here was I wanted to play a tone when a distance is detected, and I wanted the duration of the tone to be very, very small, and that way it maybe better to describe it using the opposite. Let's say I have a go for 1 second. Well, you're kind of limited in terms of like the notes you're going to play. They have to be like intervals of 1 second. So if you were to put your hand there and take it away really quickly, if you want to have a really, really very fast note or a short note, it wouldn't be able to accommodate that. So I thought, okay, if I shrink this, then I'm always going to have the most accurate measurement as possible. But that sounded not good. So it seems like the speaker could never quite warm up. It wasn't like this constant tone. It was always just like clicking or tapping sound that it was making, because I feel like it never really got a chance to produce that tone that I really wanted, because it was always stopping and starting right away, and just not not getting where I wanted it to be. So instead, I had a little workaround, and this is just using a bit of logic. So I would play a tone indefinitely, and then I would only stop playing that tone when a new distance was detected, a distance that didn't align with the start position or end position of a particular piano key. And so then in that case, there was no starting and stopping. It was just starting and stopping all the time. It was just, go forever and then only stop and redo it when you have a new note. And so that created a much smoother, more immersive kind of experience. And so I guess I go into detail about some of these design considerations, because even though it's meant to be more of a technical talk on say CMake and Conan, I want to just like really drive home that how happy I was. Like, this is the kind of challenge that I had. The challenge was focusing on the development instead of the getting ready and the prep work. And like I had said before, that I was able to just get within a day, get a Hello World going, and then about 1 to 2 weeks to do up the code and hone everything to get the piano working. So I felt like the the Conan package manager really delivered here. We have these reduced build times, and I'm saving time by not recompiling libraries. I'm able to get the binaries I need quickly from Conan. And as far as managing goes, I could quickly retrieve whatever dependencies. They're in a known location, great, and I can have this great sense of ability to reuse the same library binary across multiple projects. So who can use Conan? If your concern is licensing, it's as far as licensing goes, Conan is open sourced and it's published with the MIT license. It's multi-platform, meaning it can run on Linux, Windows, Mac OS, and anywhere actually where Python can run. So having Python would be a requirement for running Conan, I believe. And Conan is designed to support all the popular build systems for C and C++, as well as custom build systems, which are not uncommon for enterprise environments. The Conan is also very active. It has several full-time developers that are sponsored by JFrog, as well as a very active user community which submits dozens of pull requests each month. And there's a Slack channel that has over, I think it's like 2,100 members, maybe 2,150. It's one of the most active channels in the C++ community. There's free training available from JFrog Academy, helpful resources there, and documentation. And certainly welcome developers and library maintainers to take advantage of it. So from the developer perspective, like, great that that you have all this prep work and headaches sort of alleviated for you. That burden disappears because of how smoothly I found Conan was to run. And then from the library maintainer perspective, like, wouldn't it be great to see your work spread and help out and be used by that entire community? And so, there you have it. We have performant access to hardware and with tools to combat the pain points. And that's how all these pieces how I found all these pieces fit together from the command line to make to CMake to Conan. And that's it. So yeah, thank you, everyone.
Thank you, Nick. Thanks a bunch. I really enjoyed that. It's pretty impressive, this project. Let's open the floor for Q&A. Anyone? I think Jim, you had a question.
Yeah, I have a question, Nick. I was just wondering. I've my first exposure to Conan, so this might be a new question. So you were showing us how the packages are arranged, and if you were going to put multiple packages in your requirements.txt file, and let's say there were common dependencies between multiple packages, does Conan take care of organizing them so that they only occur once in your download?
Yeah, so that was actually I believe that's the case, and I think that could actually be seen when I had first gotten the request for POCO. It ended up getting it got everything I needed first, and then when I ran again, only 2 of them would have been different because I wanted the shared instead of the static, and so it was able to see, oh well, you already have these things, so let's just go ahead and get the new 2 that you need.
Okay, so even though the dependencies might exist from another package, it won't bother downloading it again when I add another package that has the same dependency.
Right.
Okay.
I think the only way that it would is if the configuration is in
I
one way
see.
or another different, and
Makes
then
sense.
you would get a different package.
Okay, just one other quick question. What's the default location for Linux for installation?
Ooh, good question. I'm trying to remember, but I can't remember that offhand.
It is the home directory .conan.
Okay.
I usually not using my home directory. Just it's usually an NFS mounted, so there is an environment variable that you can tell Conan, I want the Conan home to be there, like in a different directory, and this is what I usually. Okay. So it's and we have quota on the home directory, and also it's better to I kind of offload it to a different directory.
Okay, thanks, Nick.
Yeah, thank you.
Yeah, and I would like to add that we host Conan packages on Artifactory, which is another product at JFrog. It's very common platform from JFrog, and we use it to host binaries. Obviously, Artifactory can host a lot of binaries and packages from all kinds of formats. So Conan is one of them. And regarding the community that Nick mentioned, I had a pleasure to interact with them a lot. I'm nagging them every time that I have questions, and they are super responsive, and I really appreciate that. Usually I use GitHub to ask questions, and it's pretty much within hours it's being answered and resolved. So I'm very grateful for that.
That's great.
Is there any other questions on? I don't think there is anything on the chat, but let me just quickly check. I posted the link from Ari, so please go ahead and check it out. Oh, there is a question from Paul. Well, do you want to ask, or you want me to ask for it? So there is a question for continuous integration. Are there auto cleaning options for downloads? So I think what Paul is asking is the Conan cache is going to grow, or there is a way to limit or maybe clean it up? I personally don't know the answer. It's a good question, but I don't know the answer.
Yeah, so that's the layer of detail I haven't been able to investigate too much. Would you have any thoughts on that, Diego?
Yeah, Nick. So the thing is that the Conan cache actually stores packages without limit. There are explicit commands that you can use, like Conan remove, and then you can remove the packages that you don't want anymore. But I guess the typical question is if we have any like eviction policy or some automation. The answer is that we don't have right now in the Conan cache, but in Conan 1. But we have just released Conan 2.0 beta. We are in beta stage now, and the new Conan cache in Conan 2.0, it has a database, and the database has the least recently used timestamp for packages. So it's not used yet, but the goal of these people in the new Conan cache is exactly to implement this. Hey, I want to remove from my cache packages that haven't been used in the last week, for example, something like that. And that is an intended feature. It will not be in 2.0, most likely, but it will eventually land in 2.1 or 2.2 sometime after 2.0. So yeah, we know this is a demanding thing. At the end of the day, Conan 1, you can just wipe the cache from time to time, like weekly. It will be a bit slow. It's a cache. So you can remove everything and then start from scratch. It will be a little slower at the first iterations, but then it will eventually be repopulated.
Thank you. By the way, Diego, you had an excellent presentation in the Italian C++, I remember, where you presented Conan with all kinds of features related to developing Conan packages while developing packages while they have changes, like frequent changes, how to have this option enabled, which is really useful also for us. So I do encourage people to check out. It's recorded. It's on YouTube. It's in Italian C++. So so it's a different meetup. So I do encourage people to check it out. Any other questions? Let me check the chat. I don't think I've seen anything else, but okay. Okay, so I think we can close. Thank you so much, Nick. It was super useful and super interesting. Amazing project.
Great. I'm glad you enjoyed it.
Much. Yeah, thank you so much. And again, thank you for working on that for Conan. For us, Conan is a great tool for us C++ developers, making life much easier. For me, at least, it's a big win when I'm using it. So yeah, keep up. It's a good job. Thanks.
Great. Yeah, thank you. Yeah, thank you for having me.
Thanks. Thank you, everyone, for attending. See you next time.
Thank you. Thanks, Nick.
Thanks, everyone. Bye. Have a good night.
Bye.